Good afternoon, people. My name's Ian Tell. Just to give you a little heads up who, where, and why I've come from. I've been in Wi-Fi for about 12 years. Um, Worked for a couple of manufacturers and got the opportunity to come and work for Mojo, as we were called before we were purchased by um, Arista. The reason I moved towards Arista is because as Wi-Fi engineers or as Wi-Fi people, we have only a limited amount of information and knowledge available to us that actually we can use to troubleshoot and fix the problems quicker. So if we look at the title of this, it's easier, faster, mean time to resolution. What we mean by that is I want to be able to look at a screen, I want to be able to take a packet capture, I want to know what it says, and I want it to give me the answer. It's about working smarter, not harder anymore. So just as a quick outline here, if I can get my mouse to work. Okay. So we're going to do an overview of Arista Packets, what it is, where it comes from, the evolution of Arista Packets. Arista Packets has been around quite a long time, and the ways that we can capture and the ways we can upload this data, and some of the unique features that Arista Packets actually offers. But also how we can take packets from other sources such as Wireshark or AirTool, and we can import them into Arista Packets to again make life easier. So back in 2013, we started developing a product. It was actually back when we were called Airtight. We used to be a security company, and it was something called Wireshark. We started building the service. We developed it with a cloud integration. We allowed people back in 2015 to start looking at the API, so they can write their own scripts and their own requirements. We have a full integration with Wireshark. And we've got a community forum. So a lot of the Wi-Fi guys that are in our industry, we all talk, we all share advice, we all help each other. You know, there's a lot of conversations going on about AX at the moment and resource units and OFDM. A community within our industry is probably one of the strongest communities that I've ever had the pleasure of working with. In 2016, we renamed ourselves as Mojo Packets. And we built something called the connectivity dashboards, and I'll show you those, the performance dashboards, but we also had something in there called a client health widget, which means we could see whether the client was working effectively on the network, on the Wi-Fi. Because the problem with Wi-Fi is this. You could actually call it magic. It is smoke and mirrors in some cases because, you know, you've got 5 bars on your laptop in the corner, but actually it's really, really slow. Well, it's not like a cable where you can pull the cable and you can see the lights on at the switch and that should all work. I've got an IP address. We need to look at things such as retries. We need to look at the signal noise ratio. We need to look at lots of things around us. So it's important that we can have something that's simple and easy that actually gives us health, that gives us information. We have full integration with AirTool. So anyone that's running Macs out there, you can use our product. We have free access for a lifetime. What I'm showing you on the Arista Packets front is free. There are no licenses. There's no we're going to charge you for this. It's free. 2017, as we developed the Mojo Wi-Fi solution and the third radio, we took the intelligence from Mojo Packets and we imported a lot of that information into our access points. So now we have automatic packet capture and upload from both a client perspective and an AP perspective. But above that, when we use that information, we have what we call automatic root cause analysis. So actually, we're automatically capturing packets using Mojo Packets. We're converting that into usable information, and we're doing root cause analysis. We're telling people that's the fix. There's your problem. Back in 2018, this was a great thing for us. We got purchased by a company called Arista. Arista do some of the probably, and this is my opinion, I'm not a data center guy, but some of the best DC switching products in the marketplace, built on solid software, built on quality of the software, merchant silicon, and a single image across every single platform. And they're taking a lot of our way that we work, and we're going to be working together very closely. So let's just move on. If anyone here has ever done a packet capture on Wi-Fi, one of the things that we usually do is we'll either try and fire up Wireshark, or we use OmniPeak, or we'll use AirTool, and then we'll guess what AP the client's associated to, or we'll try and work out what AP we're trying to do. With our solution, you literally select the AP. You can use any one of these drop downs, and as you can see here, I can do debugs, I can do spectrum analysis, so I can turn the third radio into a spectrum analysis device. In this case, what we're particularly interested in is I want to do a packet capture. But what I want to do is I want to look at both the 5 gig, the 2.4. I want to look at the wide interface. I might select DHCP because I feel that DHCP is my problem. So literally, with 2 clicks of a button, I am now running a live packet capture on an access point. But above all, it's non-service impacting. We do not kick off, we do not disrupt, we do not affect the user capability. So users are still using the Wi-Fi. So if I was connected to one of my APs right now, I could run a client connectivity test on the AP without disrupting my GoToMeeting session. But it's live data that I'm capturing. Okay. Again, we do the same thing for clients. So I this information, as you see, this is Turley's iPhone. This is my home network. I get a phone call. I get a call from myself. The Wi-Fi is broken. I can't get on the Wi-Fi. The network's running really slow. I've got 5 bars. Everything's looking really pretty. And usually what we do is we ask them to turn it on and off again. Are you connected now? And if that doesn't work, if this is a campus or I'm in an office environment, I might actually wander across the site, and I'm going to take my laptop with me, and I'm going to sit between the laptop and the access point, and I'm going to try and do a packet capture of the client. Well, actually, that could be a bit disruptive. Don't know whether I do want to do that. What we do is you find the client name, you select the client name, again, you press one button. Now, what I want to do is I want to select where I want it to upload it to a server or to my Wireshark on my local machine, or I want to select all the packets on the channel, or specifically that client, and I get to see what packet types I want. This is 2 clicks. The underlying technology that is being used is Arista packets. Okay. Again, non-service impacting. The Wi-Fi continues to run. The clients continue to connect to the network. Now, one of the things I can do is I can open up my screen. I can go into the dashboard. I can select clients. I can select total number of clients, and then I can select where clients are having issues. So if, for example, I know clients are having authentication issues, I can look at authentication issues. And if we look here, again, it's non-service impact. The point that I'm making here is we're very different with the way that we do client connectivity testing. We don't have to go out and buy third-party modules that we stick on a desk or we wire into the network. We use the AP with the radios and the information and technologies that we have built into the APs. Again, straight away, as I've dropped down into my client, I can see what access point I'm associated to. I can see what version of iOS I'm using. I can see that actually my iPhone's broken. It's not a sticky issue. Yeah, I'm on 2.4 gig. Hang on a minute. Oh, hang on. You typed in the wrong PSK. Our system will tell you you've typed in the wrong pre-shared key, but that's easy. Any manufacturer should be able to do that. We do something a little bit different. We have something called a ring buffer in our APs, which means we capture a lot of information for the clients, and we hold that information for the clients for 7 days. Now what I can do is when you ring up and say, Ian, I can't get on the Wi-Fi is broken, I can type in your MAC address, your username, device name, asset number, and I can call up your logs from 7 days ago and tell you why you failed to connect on it. As you can see here, I was connected on channel 44. I've got the correct IP address, yada, yada, yada. I've changed SSID. Now I've got the incorrect PSK. So what I do is, because I've done automatic packet trace, I select that. I now select open. And what that does, that goes into a packet trace. And what's interesting about this is the packet trace that we do is not going to give you 5 million packets of information where you have to scroll through. The problem with scrolling through all of this information is you can go packet blind. You can miss things. You might not know what the radio header types mean. You might not actually realize that the problem that you have is adjacent channel interference. So you're looking at the packets, you think you're on channel 6, but actually your APs are transmitting on channel 1. This is a problem. What we do is slightly different. We take the PCAP packet capture. We drill down into that. We take the format, and as you can see down this side of the screen, we have everything from our ACK, control traffic, probe response, dissociation, association request, EPOL types, EPOL keys, DNS, DHCP. But we've turned it into a simplified GUI format. If you've ever done a four-way handshake using a pre-shared key, you see message 1 of 4. Great, I'm now transmitting. I get message 2 of 4, and then I see 1 of 2, 1 of 2, 1 of 2, 1 of 2. Well, actually, that means I've typed in the wrong pre-shared key. I'm not getting the authentication back from the AP in simplified terms. But if I hover over these, you can see that the first message, I now got the second message. The next message I'm going to show you is actually a message 3, a message 4, and now I'm connected to the network, and now I'm sending data. What does that mean to me? It means actually I can give my level 1 support guys a tool such as this. I can give them basic training, and now they're looking at packet captures. They're automatically doing packet captures on the fly with your client devices. They're checking the network, and they're giving information back to the correct team at the right place. Because let's say this wasn't a 4-way handshake failure and it was an EPOL failure. Let's say we've worked out that EPOL failure and we know that EPOL failure relates to an unreachable radius server. If I can't reach the radius server, that's one of two things. I've either lost my WAN connection if I'm doing this remotely, or maybe the radius server's down. Now I escalate to the radius team. It's now passed away from the networking team. I haven't spent hours troubleshooting the network, trying to do a packet capture, disrupting the Wi-Fi network. I actually have information that my layer 1 support guys can take and push up to the correct team. Now, when I want to push this up to the correct team, I might want to escalate this to Arista support because I don't know the answer to the question. Well, actually, I can share this information and we can be collaborative. We can work together. Now you take that packet trace, you copy it to a clipboard, you send it to support@arista.com, or you send it to layer2@endusercompany.com to raise it up to the next part of the train. You've got the packet capture there. You don't have to do the packet capture again. It's working smarter, not harder. I don't have to redo packet captures. I don't have to send someone a packet capture where they can try and guess. We can look at the same screen. Does anyone? I don't see any questions at the moment, so that's positive. Well, not positive, but it must mean people are taking this on board. So when we look at let's just go back here for a second. Sorry, we looked at frame view here, and what I want to do next is I want to drill down into the actual frames. As I said to you before, 1 of 4, 2 of 4, 1 of 4, 2 of 4. The information that we're showing you right here is the same thing that we have in the previous slide with the green box, the 1 of 2, 1 of 2 of 4. It all depends on how you want to view this timeline. It all depends if you want to look at the frame view or whether you want to look at frames. Here, we now have a successful 1 of 4, 2 of 4, 3 of 4. Now I start my DHCP discovery process. Well, actually, let's say we did this 1 of 4, 2 of 4, 3 of 4, 4 of 4. I start my discovery process, but I don't get a DHCP address back. Well, actually, You'll see that in this. I said earlier, we work with AirTool. You can literally download the product, you can open up the product, and you can download the integration into AirTool. Very simple, very easy, very clean to use. Again, we integrate with Wireshark. The object of our solution is to try and make people's lives easier. Whether you're using the latest Samsung S10 or whether you're using an old Dell laptop, we have to use the same protocols. If we don't use the same protocols and we don't use this, we can't work together. By using something like Wireshark and Arista packets, we can take the packet capture from the oldest device to the newest device, and we can see the correct packet formats. You'll notice that I've got these are Mojos. This is a Mojo slide here. The reason I've used it is because it has a little bit more data than my home network. My home network doesn't have that many clients on it, to be truthful. So I just grabbed some slides here. But here, I can look at the connectivity dashboard. I can see that I've got 50 clients on my network. 17 of them are healthy. 33 of them are idle. But one of them is an unhealthy client. Why is he an unhealthy client? I can see the client type. I can see that he's classified as unhealthy. I can select that client and I can see he has an EPOL failure. We're now putting this information into a GUI format. That packet capture, that Wireshark trace, that AirTool trace, that OmniPacket capture, you can import it into this. The Ekahau Sidekick. You know, I suspect there's quite a few guys on this call that are, you know, Ekahau customers that may well be using a Sidekick already. You could do the packet capture on a Sidekick and put it into this. And I'll show you how to do that in a minute. I'll show you how simple this is. But we can start looking at the clients again, seeing how healthy our clients are. We could drill down into them. We could look at retransmissions. Retransmissions are not a good thing, really. So do I want lots of retries? Well, no, I don't want a lot of retries. Data frame retries at 34%. Ooh, slightly high. Management frames. Well, there's a lot of management frame going on here, but I can also look at my latency for my clients. The object of this is to give you the information in a GUI format that you can push back into management. You can push back into a support team. I can actually look at the clients with the lowest RSSI. This client here might well be connected at 81 dB, but hang on, he's transmitting. He's not in the high retry level. Let's have a look. See D3BA. And no, he's not in the high retry. So these guys aren't retransmitting their data. Well, that's quite useful. He's far away, but he must be hearing it cleanly. But this information, look, we can see the transmission, the TX and the RX megabits per second. We can look at the max data rates and the min data rates. We're trying to give you useful information. If I look at this client at neg 59 and his minimum data rate is 6 meg and his max data rate is 65 meg, is that a good thing? It might not be. It might not be a single stream client. If it's a single stream client on 2.4, it could be. The point is we're no longer guessing at Wi-Fi. We're giving you information that allows you to put it into a GUI format that allows it to be presentable information. What I particularly like about this slide is it looks like a mess. But when I drill down into it, I can actually see that the size of my frames, my data rates, I can see that I've got connectivity. What's actually interesting here was this was taken off an Xbox One, and it didn't have the correct minimum BSS set. But the sizes of the frames are very small. The majority of the frame types are less than 200 bytes. Most Wi-Fi traffic is anywhere between 256 and 512K. Now this presents that information in a usable format. This is where we get into our root cause analysis. Therefore, I've lost the problem. I've connected to the network. I've got 2 of 4. I've got a problem. I can't connect. Our root cause analysis actually tells you you've typed in the wrong pre-shared key. There is no more of this arguing. It's, sorry, you've typed in the wrong pre-check. No. It's not a capital 0. It's not a capital O. It's a 0. Or it's not an L. It's a 1. You know, when we're typing these things on iPhones and stuff like that, it's a very easy thing to do. And yes, I know that a pre-shared key is not the most secure form factor. And really, if we're going to do it, we do 802.1x as the gold standard. But sometimes we want to make life easy. We want to use things like pre-shared keys to make things a little bit easier, a little bit accessible, especially for headless devices, IoT devices that are, you know, they don't have the capability to have 802.1x. So, my final slide here. Sign up for free. Yes, it's free. The auto packet resolution and stuff on our interface isn't free, of course, because you have to use our APs. You have to use our third radio. And we're going to be doing a presentation on that within the next few weeks. And we're going to show you how this all ties together. How when we use our largest customer that has 193,000 access points on a single platform, and with the failures they get, it actually allows us to learn from big data, and we can fix the problems instantaneously. So hopefully you've all made a note of that. Just while I'm moving on to another screen, do we have any questions out there? Has this caught anyone's interest? Has anyone got any questions?
We've got a couple of questions. I think you may have already answered them, but let's just go through them again.
Yep.
Do you have to use Arista infrastructure to actually use this solution?
No, not at all. The Arista, the Arista packets, as we showed you there, is just a free piece of software. So you could actually use Cisco APs or Ruckus APs or Netgear switching. As long as it's a PCAP format, we can use it. We can import it into the software, and it will give you all the tools.
Fantastic. And another question, and again, I'm not sure, obviously, what the answer will be to this one, but obviously, if you have a capture of Wi-Fi 6, as in AX, is this something that it can be decoded?
Easy. So that's a really good question. I quite like that. Wi-Fi 6, as we know, is not a ratified standard yet, and I suspect we're going to see lots of interesting things with the radio headers, with the resource units. When we start using multi-user MIMO on the both the uplink and on the downlink, when we use IFDMA and when we use BSS coloring, they're all standard features. We see it in a radio header and we see that VHT format. We'll take that information and we'll just put it into packets. Very simple, very easy.
Fantastic. To be honest, mate, I mean, I think there's a couple of repeats of the same questions around is this free and obviously in terms of infrastructure, but I think you've pretty much covered those.
So let's just show one thing quickly. This is my alpha server. The only thing we're interested in is packets alpha, so it's actually part of our system as well. I just want to show, my friend Richard Shelford did me the kindness of doing me an Ekahau Sidekick packet capture last week, a couple of weeks ago. I'm going to now go into this. He sent me the file, okay? I'm going to double click this. And oh, hello, I now have an Ekahau, you'll see it processing just here. It's now processed. I can now drill down into a packet capture that we've taken from a Sidekick in all of 15 seconds. And look at the information that I've got. Look at this. This is great. So when you combine the Arista packets with something like an Ekahau Sidekick and the capability to capture traffic on capture packets on the fly, you have a fantastic solution. Combine it with our APs, you have an even better solution. Any questions? Anything else? I think I've got that nailed down quite well, and people can carry on with their day. I think 26 minutes, not bad. I haven't spoken too long this time.
Very good. No, I think we've exhausted all the questions. So I think unless anybody would like to talk to Ian directly, which we'll hold on for 30 seconds or so just to get any show of hands or any further questions coming through, I think we'll end that one there today. So, I mean, Ian, in terms of sort of packet capture, is this something that's going to be a big part of the development for Arista going forward?
Oh, definitely. We're still going to be developing this solution. You know, as I said earlier, the reason why I moved to the company is because we're giving people the tools to fix Wi-Fi without having to spend 15 years learning the stuff. You still need people like me and Mr. McKenzie, who's a CWAP and CWNEs, but it makes life easier. It can be escalated in the right way. So there's a lot of development still ongoing with this. Yes, indeed.
Fantastic. Okay. Well, I'm not seeing any more questions coming through. Nobody's raising their hand, so I think, my friend, you've done a fantastic job today. So I'd just like to thank everybody that joined us and obviously giving us the time to show you the presentation today. If you do have any questions, then please do reach out to us. The account managers will be only too happy to answer any of your questions after the session today, or if you need Ian to go into something in more depth, I'm sure Ian or one of his colleagues would be very happy to get involved with any sort of bigger questions. But for the time being, thank you everybody, and have a great rest of the day.
Thanks, guys. Hope everyone has a good day.